Molibdenio team, and this is our technical demonstration video.
Hello, I'm Kyle and I am responsible for the construction of robots and the spacecraft programming.
Hello, I'm Gabriela, and I'm responsible for the panel and ET's programming.
Hi, I am Giovanna and I am responsible for the communication, screen programming and the visual design.
Hello, I'm Ian and I'm responsible for the robots construction and electromechanical parts.
Hello, I'm Lucas and I'm responsible for 3D modeling and creation of the game.
Aiming at the idea of sustainability and clean energy, we decided to not use batteries in our robots. Instead, it will be a bicycle that will generate energy and start the presentation. It will do this through a DC motor being used as a generator connected to the back wheel. We made a printed circuit board, a PCB, which contains 4 capacitors, a voltage converter, and a diode. After the energy passes through the filtering and voltage regulation station, it will feed the robots. Because clean energy is so important in our society, we choose it as a feature. The bicycle will also control the movements of it through ER distance sensors model D8, which will detect the front wheel's movement and plates attached to handlebars.
We chose the panel as a feature because of the technologies involved in it. For its construction, we use large motors from the EV3 Lego kit to move the X and Y axis. The panel's movements are mainly coordinated by tooth belts. This design was inspired by the mechanics of a 3D printer. To decrease the panel's weight, we chose using elements bars instead of wood used on the last project. We prefer to use these motors in light of its precision. The 3D impression was chosen because it eases the construction. The panel's PCB contains capacitors, a H-bridge, and an Arduino Mega. These boards controls the motors in a closed loop, making the movements according to a message received by serial from unit. This communication was chosen as a feature because of the innovations that it can make.
To control the panel's bicycle and compose the extent, we used the unit with Vuforia extension which allows the manipulation of audios and videos that will appear on the screen. With the augmented reality extension, it is possible to control the bicycle on the panel by moving a maker in front of it. Based on the position of this maker, the coordinates will be sent to the Arduino at the panel. In addition, virtual bicycles will appear, riding along with the real one on the panel and allowing a dynamic interaction with the presentation. We selected augmented reality as a feature because it is a new and promising technology, making visual effects as well.
The two robots will move to the spacecraft, talk and have facial expressions. Each was processed with foam, PVC pipes and paper mache. It will move according to the position of bike's wheels and will have an IR sensor to stop. Together, it has 3 servo motors for facial expression and 3 dynamics motors for rocking and lifting its arm. The PCB has an Arduino Mega, a voltage converter, capacitors for a more safe regulation of energy, transistor, resistors and inputs for servo motors and dynamics. It will also have a voice-to-module communication with the public. While walking towards the spacecraft, promoting interactive and fun presentation. Made with styrofoam, printed pens, and aluminum profile, the spacecraft has LED strips that will light up during the presentation. To control it, we used a PCB with an Arduino, a transistor, and 2 capacitors for different voltages between the Arduino and LEDs. When the two robots arrive at the spacecraft, it will be detected by a ultrasonic sensor and the spacecraft will rise, ending the performance.
Among the challenges faced during the project, we can mention the communication between Arduino and the unit. Since they are different platforms, it was hard to find content about the subject on the internet.
Besides, the construction of it was also complicated because it required various mechanicals and artistic techniques. To cut the foam, we used a style foam cutting machine which, when in contact with it, released a toxic gas, so to protect ourselves, we had to use PPA.
Another challenge was to stabilize the voltage in the start of the pedal. The variation could damage the memory of the microcontrollers, so it was necessary to use a relay that's an electrical mechanical component. We started the pass of energy with 16 volts. However, after start, it continues to provide energy with 14 volts or more. We also put a voltmeter to the cyclist, myself, have a control of the amount of voltage being sent.
We also created a game based on the film E.T., the extraterrestrial, using the game engine Game Maker. The player's goal is to dodge various obstacles and get to the spacecraft. We published it on Jack Games and made the car code available for the public to play.
Thanks for watching. Bye!